So I have been building this APK scanning tool, which technically allows you to scan your APK files before you push them for production or maybe deploy it on the Play Store. For static vulnerabilities, of course. For dynamic vulnerability, you will have to sandbox the entire APK file and then run your tests accordingly. Maybe add some LLM layer on top of that in order to achieve the dynamic testing profile. But for now, what I have created uses three things. It uses JADX, it uses APK tool, and it uses semgrep to give you the report on the vulnerabilities, static vulnerabilities in an application. So let's just fire up the project. I will just open my terminal. I guess the Docker containers are already on. Okay, they are already on. What would I do then? I would just go inside the project root directory. I have named it Sandboox, don't ask me why. pnpm dev. It uses turbo repo, which is like a mono repository. I used a mono repository because I wanted to deliver it maybe on some EC2 container and then run the things over there. So now what? I have a worker application, I have the front end and the HTTP backend. For keeping things simple, I would first explain you the HTTP server. For now, just remember that this thing is written in Hono, and Hono is nothing but a server-side language, server-side framework actually, written in Node.js. Of course, it is written in TypeScript, JavaScript. And then you have the worker, which uses bullmq, and Redis for cached requests, cached queuing for the APK files. Let's say a lot of users are testing the application at once. The bullmq worker would actually queue all those jobs into Redis where they would be cached. Now that's it about the part. I would explain the architecture later, but this is the working of how this application technically works. And before showing you the thing, I would like to thank a friend of mine who really helped me with the idea, and I got the idea from her. So yes, the entire idea, the entire execution, my approach might be different, but the idea was hers. And here it goes. I will just keep my terminal on maybe some other window, and then I will go back to the first tile again. I will open Firefox. I will keep it in full screen so that you can take a look at it better. Now this is the landing page. Nothing special here, just the green tinted website. I would add the documentation later on how to configure it for yourself, for your own application. For now, let's just get started. I have only tested 2 applications as of now, but I can create more, but the processing would take a lot of time, so I'm just saving all of that time, or maybe just I will show you how it works on the back end. So I will just click new project. I will go on APK scanning. Web audit, it's something that I have planned for the same application. I will just go here and call it test APK, and then I would leave it blank because it doesn't matter. Then I will go, and I have this test APK which I downloaded from I don't know, APK Pure, and then I will just paste it and I will initialize the workspace. Now as soon as you add a project into this, you can go here and then just run the scan. In the background, 3 things are happening. First, the APK file is being decompiled into the source code. JADX has its own folder, and then the APK tool has its own folder. Both are good for looking at the source code, looking at the manifest, and then they are being pushed into semgrep in order to run the static analysis. So yes, semgrep is being used at the backend here. Semgrep is a static analysis tool which is used to find vulnerabilities in Java code, Kotlin code. It supports a lot of languages. So, yes, it is running on top of that decompiled code in order to find vulnerabilities. Now, as soon as this thing is processed, let me show you the logs. It takes a lot of time. Maybe if I exit full screen and go back to the terminal, it takes a lot of time since the decompilation procedure of the APK file is, well, it is computationally heavy, and add semgrep on top of it, so you are utilizing over 2 to 3 GBs of RAM. So yes, I would have to think about my deployment options later because there's only so much you can do with a free tier EC2 container, and sadly I don't have the EC2 container anymore, so I would be running out of RAM every single time a person tries to decompile their files. So let's just wait a little longer, let it do its thing. Maybe it will just work, maybe it might fail because the timeout is only set for 5 minutes, and if it exceeds 5 minutes then the APK file would not be compiled. So let's just wait. Okay, the job is finally complete, and it was tested against multiple static filters. Now we will go back to our application. As you can see, the status is now set to complete. I will open it up and then I will go to the report. The report is great if the scoring system was decided by me. Like the more warnings the vulnerabilities give, it's like -5 for each vulnerability over here that you can see, and for the critical ones it's -10. So yes, this scoring system was suggested by CVSS scoring system, and I did add some more mix of my own. And then I can just go and take a look at the permissions. The green ones are like labeled as normal protocol. The red ones are dangerous protocol. You don't have to like provide them with the permission related to these things. They should not access, like they cannot, this application has access to write on external storage, and this is a dangerous protocol because it is affecting your file system in one way or the other. And then you have the signature protocol, which in my opinion is not big of a deal. You're just connecting to the internet. The application is trying to connect to the internet, to the Wi-Fi specifically. And then you have the manifest. The manifest is nothing but the APK's compiled, how should I put it? Compiled data, I would say. And then you can test it for network security, you can test it for cloud backups, you can test it for clear text input output, compiler debugging, stuff like that. And finally, if you want, you can export the findings as well. So let's just click on export findings. And you have the findings compiled, and I have only mentioned like the vulnerabilities over here. I still have to fix the React code for it, and you can just download it on your machine. So let's do that. I can save that. That's pretty much it. That's pretty much it about the application and how it works. Coming back, it only allows you to test the APK files which are publicly available. So if you are dealing with a private repository, maybe a private APK file, this application might not work because I still haven't added GitHub API or maybe GitHub token parsing for your own private repositories. Because as good as this project sounds initially, it has its own security questions. Like, I'm taking your APK file, and the question arises, are you storing them? I'm not storing them. They are being decompiled, and the report is being generated. As soon as the report is generated, the files, the JADX folder, the APK folder, it is all being deleted, it is all being cleaned. So yes, there is no way these things are going to stay on a server. Of course, if somebody wanted to do that, they would have done it, but on free tier, I really don't want this application to be computationally heavy. So, yep, that's it. I'm still looking for my deployment options. And once it is deployed, maybe some more things would be changed along the way. That's pretty much it for now, at least.